Okay, I've also printed for you another little table which explains bulbs in series and bulbs in parallel, and we will be using it to answering the experiment step 1 to 5. So the points of comparison for the two is, the one is the series and the one is the parallel. I have sent this on a photo for you on WhatsApp as well. So let's look at the series. The series says the number of paths for the electric current is only one path. Remember, if you look at that little picture there, you will remember the series only have one path to go through. It only has one way to go through those lights. It doesn't have the option, if one of those bulbs fail us, to take another route. So in series, only one path, the current passes through the components one after the other, like shown. In parallel, two or more paths current splits up and passes through each branch at the same time. The paths are independent of one another. That's why if we look at this picture, we can see if that little bulb breaks or the wire breaks in that current, it won't let the whole the parallel connection go dead. The power won't go off completely because it still has another route. If it doesn't go in there, it can still go on to the next one, as is differing from the series, because if we take one bulb out, there is no supply because they are connected one after one another. That is what that explains. The brightness of your bulb will dim. The more bulbs in series, the dimmer your lights will be. Remember, each little bulb is actually a resistor. In other words, the more I put into series, it's almost like you have to break through a brick to get to the other side. The more you put in there, the harder it's going to get you to get to the other side. So the brightness will dim the more light bulbs there is in series. In parallel, the more there is, the brighter it will be because the route splits up. The current has another option to go. It's almost like if you look at the flow of traffic. When there's only one road to go, the traffic flows very slowly. The moment there's 3 or 4 roads, like in Cape Town or in Joburg, it's like it splits. So it's stronger. So the traffic goes faster. So in this case, the lights will also shine brighter. If one bulb is removed or damaged, like I've explained in the previous picture, the electric current cannot flow through the circuit. The remaining bulb will not light up. So it will close it up. For parallel, your electric current can still flow through the other path and the other bulb still lights up. So it doesn't take the whole circuit out. The parallel connections are used in the connection of circuits in the house, the twinkling lights, the bumper cars, and fun fairs. Okay? Series is sometimes used in those holiday lights, the Christmas lights outside. Okay. Let's look at another table. I've also sent this. Let's just go through it again. The current for the series, the current through the whole circuit is the same throughout and is equal to the total current applied by the source. In other words, whatever start off with, it will end off with. The current through each pathway of the current adds up to the total current supplies by the source. Okay, so each little road it takes adds up. The voltage across each of the loads of the circuits add up to the voltage supplied. The voltage across each of the loads in the circuits are equal to each other and to the voltage supplied. Okay, we're only looking at the current and the resistance, so don't stress about the voltage too much. Resistors placed in series increase the total resistance. Remember what I've told you about those bricks? As a result, the total current throughout the circuit decreases. So as your resistors in series increase, your current decrease. The resistors placed in parallel decrease the total resistance of the circuit. So as a result, the total current throughout the circuit increase. as the resistors placed in parallel decrease, it will increase the current through the circuit. Can you see the difference? Okay, I'm going to pause there and I'm going to send you a new video explaining the experiment.